In this video, we will go over how to write net ionic equations. So when you mix two aqueous solutions, such as ammonium nitrate and sodium bromide, both of them are aqueous. When you mix them together, you will get some sort of reaction. Now, in this particular case, if you notice, when we mix ammonium nitrate, NH4NO3, with NaBr solution, sodium bromide, we do not get any precipitate. That is to say, no solid begins to form. Same thing also when we mix ammonium nitrate with sodium sulfate, as seen in test tube 2, and sodium hydroxide with ammonium nitrate, again yields the exact same situation where there's no reaction. Basically, nothing is happening in terms of the formation of a precipitate. And finally, looking at test tube 4, when we react ammonium nitrate with sodium carbonate, nothing really happens. We have no reaction one more time. So let's go over the origin of why we have no reaction. Let's take, for example, the reaction with ammonium nitrate with sodium bromide shown in test tube number 1. So the most important thing that you have to remember is that when you have an ionic compound in water, it dissociates, dissolution. So by dissolution, it actually splits apart into its component ions. So as an example, sodium bromide with ammonium nitrate. Sodium bromide in water, since it is ionic, is nothing more than sodium ion and bromide ion. Ammonium nitrate is nothing more than ammonium ion and nitrate ion, seen below. Now, what happens is that the sodium ion will react with the nitrate ion, giving you sodium nitrate. As we know from the solubility table, all nitrates are soluble. That's probably one of the most important aspects of the solubility table in terms of easiness of memorization. That is, all nitrates are soluble. So sodium nitrate, having been soluble, is nothing more than sodium ion and nitrate ion in water. And the question is, what is ammonium bromide? Is this going to be a solid or is this going to be aqueous? So for that, we look at the solubility table. So the solubility table for bromide, what we see is that bromide is generally soluble. Right? There are exceptions. The exceptions are silver bromide, mercury bromide, and lead bromide, but we're not dealing with those exceptions. It is soluble. The ionic compound is soluble. The case in point here is ammonium bromide. Since it's not one of these exceptions, ammonium bromide is soluble, and it will dissociate into its ions of ammonium ion and bromide ion. Now comes the part where we cancel out what are known as spectator ions. So you can see here that the sodium ion here will cancel out with the sodium ion here. The bromide ion will cancel out with the bromide ion. Ammonium ion cancels out with the ammonium ion, and NO3 cancels out with NO3 minus, the nitrate ions. They all cancel out, and basically what you see here is no reaction. It kind of manifests itself right here in the first test tube. In fact, all 4 of these test tubes display no reaction. We can do the same thing with a second example. Let's try ammonium nitrate with sodium carbonate. So ammonium nitrate, all nitrates are soluble, is nothing more than ammonium ion and nitrate ion. Sodium carbonate is nothing more than sodium ion and the carbonate ion. The sodium ion will react with the nitrate ion, giving you sodium nitrate. Again, all nitrates are soluble. The key point here that we have to ask ourselves is, what is the situation with this ammonium carbonate? Now, this ammonium carbonate is its product. Will that product be solid or dissolve in its component ions? So carbonate here is shown here. Carbonate is actually insoluble, but there are exceptions, and the exceptions is ammonium. So normally this would be a solid, that is, it would precipitate out in water. Remember, all of this is in water. But we always have to keep in mind the exceptions, and the exception is ammonium. So ammonium carbonate is an important exception to insolubility. That means it's soluble. So ammonium carbonate is nothing more in water, because it's soluble, of ammonium ion and carbonate ion. So like in the previous example, spectator ions exist, but they exist in solution. The sodium ions, carbonate ions, ammonium ions and nitrate ions, all are spectator ions. So what we expect here is not water, but sodium ion in water, bromide ion in water, and ammonium ion in water. Same thing here in test tube 4. We expect sodium ion in water, carbonate ion in water, nitrate ion in water. All of these are essentially spectator ions. So here's an example of net ionic equations where it will yield no reaction. This is one part of the answer, but the final answer is actually no reaction because there's no precipitate, as seen in this demonstration picture